Hi everyone, my name is Felipe Peña. I'm here to present the advances of my graduation project. My graduation project is a functional prototype that is able to automatize the correct pasting of microsystems that are developed and manufactured in the Smart Industries Lab in the Universidad de los Andes in Colombia. First, as an introduction, I'm gonna give you a little explanation of how these microsystems are being based, so you can get an idea of how my device will work. Okay, seeing this diagram right here, you can see these two little blue rectangles. These are the representation of the microsystems, and the correct way to base them is that you have to use ethanol or methacrylate to as a glue to paste them. Also, you have to put them in a heater that is represented by this red circle, and also you have to put a weight just upon all the systems to make pressure to them while they are being pasted. And the weight is gonna be is about 5 kilograms, and the heater have to reach about 90 to 100 degrees Celsius. This process will take around 9 to 10 minutes. Okay, now in this I'm gonna present you my final design that was approved by the Smart Industries group for the development. Okay, this is the final design. I'm gonna show you all the components. The first one is here. This little cube here is the voltage source that is gonna reach about 12 DC volts. This is a voltage source used usually for 3D printers. So as you can see, my design almost use the same components, so this voltage source will function correctly in my design, in my solution. This around here, this rectangle is gonna take in this rectangle I'm gonna put all the electronics, so the design will look organized. Also, I'm gonna put a LCD here, so the user can be able to control all the system. Also, as you can see, I have two steppers here. I have here a bed where I'm gonna the user is gonna put the microsystems when he wants to paste them. As you can see, this have a little hole because the hole has measures that have the microsystems. So when the user put the microsystems in there, the microsystems are will get well pressure, get well attached here. Also, the bed has a little hole here for the PTC heater. That for the heater, I'm gonna use a PTC heater to heat all the bed and heat the microsystems in the process. Also, I have the weight here that is gonna move up and down like this using these tapers. So now in this I'm gonna show you how the process is. First of all, the user have to set all some values. The user have to set the temperature he wants to reach with the PTC heater. He also have to set the amount of weight that is gonna fill the microsystems in the process, and also the user have to set the time of this process. When the user set all these parameters, the process starts. When the process starts, first the steppers move down the weight until it gets here, pressuring the microsystems. Then the PTC heater will turn on, heating all the bed and the microsystems in there. And this process will stay for around 10 minutes or the time that the users just set it. Okay, when the process finish, sorry for here for this. When the process finish, the heater turns off and the weight go back to the original position. So go back here. It can go back to the original position with a end stop that I'm gonna put here in this part. Okay, now in this I'm gonna show you the simulation for this process. And the simulation, I made the simulation with Proteus 8 and with the Arduino. First of all, I'm gonna I just forget it, but I'm gonna I just remember the way I'm gonna control all this is with a Arduino Mega and RAMs 1.4 that is normally used for 3D printers. If the ones that are seeing this video know about 3D printers, will automatically recognize this shield. This shield allow me to put all the components that are necessary for my design. Components like the steppers that you just see in my design, the heater that is here, the heating sensor, the temperature sensor, I'm sorry, and this so to explain you more precisely, these pins around here are for the LCD. These pins around here are for the driver, for the steppers. Here are the inputs for the voltage source of 12 volts, and here are the outputs to control the heater. So okay, now in this I'm gonna present you now. Already I'm gonna present you the simulation. So if the user turn on the voltage source, the LCD will show this menu. This is the main menu, and I have three options. The first option is use LCD. The user is gonna click this option if he wants to control the system using the LCD. Also have the option to control the device using an app that is gonna be available in your PC desktop, but right now it's not programmed, so I'm gonna skip this option. Also, the user have the option to change the language of the LCD. You can change it to Spanish. So as you can see, the language you just change it, but for purpose of this demonstration I'm gonna use English, even though the Spanish language is completely functional in this simulation. So if the user wants to control the process, he wanna use LCD, as I said. So here we get to a set menu. That is where the user can set these parameters, the temperature of the heater, as I said. Here he can set it. The default set is 100 degrees Celsius. He can also set the weight, that the pressure that the microsystems are gonna feel. The default one is 5 kilograms of weight, and also the user can set the time of this process, and the default one is 10 minutes. So I'm gonna change it to 7 minutes on purpose of this demonstration. I have to say that I changed a little bit the code. That is gonna, because in this demonstration the time is not gonna be in minutes, it's gonna be in seconds for this video to last not so long. So now just saying this, I'm gonna initiate the process. So I'm gonna click initiate. So as you can see, the process initiate. If you see here, there are the steppers. They start to move, putting down the weight to the position that making pressure to the microsystems. Okay, it gets there, and when it gets there, the heater starts to turn on, and it starts to elevate the temperature of the bed. As you can see, the heater is getting hotter. If you see here, the parameters are in real time. Here is the temperature, here is the weight that is not programmed right now, and here is the time. When the time reach 7 minutes as we set it, the process is gonna finish. And you see here that the temperature is getting higher because the heater is on. As you can see, the temperature is actualizing in real time, in actual time, so the user can see the values of its parameters during the process. If the user wants to stop the process, he can click on stop here, and the LCD is gonna ask if he wants to stop the process. Yes, if he wants, the user have to put yes if he wants to stop the process, and no if he don't want to. So as I don't want to stop the process, I'm gonna put no. So it gets back to the process screen. The temperature also has been elevated, being higher while I was doing this process, and the timer has been elevating too. We have to wait until this get to 7 minutes, and it's gonna change the screen, finishing the process. So we have to wait just to 6 minutes, and finally it gets to 7 minutes, and the heater is off, as you can see here, and the steppers go back to the original position. Okay, as you can see, the steppers get back to the original position, and the heater is off, so the process is finished, and the screen shows it that the process is finished, and the systems get back to the original position. So you can get back to the menu and click back to menu, and the user can start the process all over again. Okay. Now I'm gonna show you the design of the bed. If you forget it, the bed is this one that's gonna have the microsystems and the heater. This is the final design of the bed. It's divided into two parts. The first part is here, as you can see, has the perfect measures for the PTC heater. If you want to search the PTC heater on the internet, you will see that it has almost these measurements. And also the second part that's gonna be in the upper part is the bed where the user is gonna put the microsystems. Here, this hole here, it has the measurements of the microsystems that are used in Smart Industries Lab, and also have these like holes here. These holes are made for the user to take off and on the microsystems without this microsystem get attached during the process. So I'm gonna put this to the final position. So is this the problem? Is this problem? Okay, you get a little bit of the idea. This match perfect. So as you can see, you have almost the same like look. The first part is for the heater, and the second part is for the microsystems. This part is gonna be in metal, so when the heater gets in contact with this part, is gonna all this part is gonna be heated, because as you know, the metal is a heating conductor. Finally, I'm gonna show you a little bit about the code that is used to control all the systems and make function this simulation. This is the code right now. This is the main slice where all the all the design functions, all the methods of the different slices converge into here. So this is the main one. This is the slice for the stepper. This is slice have the methods for the stepper. This slide has all the methods of all the slices that are used here in the main slice. Here is the slice for the heater. As you can see, control the heat. Have the methods that control the heater. And here is the slice where it controls all the screens, as you can see here. I'm showing you this because I'm trying to comment all this code, because when the project is finished, I want to release this code, so the ones that use my design, if they want, they can see the code and see how this design works, or even though if they want to develop much more the design, they can do it taking this code. So this is all for now. These are all the advances for now. I miss the real materials to prove them physically. So right now, these are all the advances, and thank you for watching.